Hello, everyone. Welcome to Unit 1, Day 5. Today, we're going to talk about our first method for organizing data once we've collected. We're going to talk about these things called frequency tables. And our goals today are to be able to analyze frequency tables, build frequency tables, and identify key terms and properties of the frequency tables. All right, so there's going to be some vocabulary that kind of surround these things called the frequency tables. So we'll kind of go through that, and I'll show you how to find those different key terms. All right. So you got to imagine if you are conducting a research study, what would happen is you would figure out what it is you want to study, figure out what population it is you're trying to do the study on, and then you would go out and you would sample a part of your population. So you would say, okay, well, I'm going to go out and I'm going to collect a cluster sample from the population, and I'm going to get some raw data, right? And so let's say you went out and you sampled 20 students and you asked how many hours they worked per day, right? And they give you their responses. So now you have this raw data, right? So you got 5, 6, 3, 3, 2, 4, 7, 5. Right, so once we have the data, we need to find a way to organize the data in a way that makes sense so that we can start drawing conclusions about it. All right, and the frequency table is a really good way to do that. So let's take a look here. So first, let's just talk about frequency. All right, so the word frequency literally means the number of times that something occurs, right, or that something happens. In our case, it's the number of times that a value of data occurs. Okay, so if we're looking at our data up here, I might say, well, what's the frequency of 2? And you would say, okay, well, I'm looking through my data and I see a 2 here, a 2 here, and a 2 here, right? And I can underline those. Right? So we see a 2 happens 3 times. So the frequency of 2 is 3. All right. We're also going to see this thing called a relative frequency, and there's a lot of wordage here, but the simple way to remember relative frequency is what percentage of the data, right, is a particular value. So if I said what percentage of the data is a 2, you would say, okay, well, there's 3 2s and there's 20 total pieces of data, so 3 out of 20 would be our relative frequency, right? Whatever percentage is yielded from that. All right, and then we see a cumulative relative frequency, and that is where you kind of add up the relative frequencies as you go. All right, so here's an example of a frequency table. All right, so we would arrange it, we would look at all the different data values that exist, and we would give each of those their own class over here. We'll talk about what a class is in just a second, but these would be considered our classes. And then we would say, okay, well, when we went through the data, the number 2 appeared 3 times, which is 15% of the data. And up to that point, that is a cumulative 15%. All right. Then we would repeat that for the data value number 3, right? We would go through our data and we say, okay, how many times does 3 appear in our data? And we say, okay, well, it appears 5 times, so that's the frequency. And then that would be 5 out of 20, so that's 25% of our data. And cumulative up to this point, that would be 40% of our data, right? So we would say, because we would have to take the 15% from before and add the 25% to it. So we would say 40% of our data is 3 or less. All right. We do the same thing for 4. So one more time here. So we would have the data value 4. It appears 3 times in our data set. So just the raw number of times that it appears, that's the frequency. And 3 out of 20 is 15% of our data. That means 15% of our data are 4s. And then up to 4, right? If I added all those relative frequencies up, we would have 15 plus 0.25 plus another 0.15, which would give us 55%. So we could make the statement that 55% of our data is 4 or less. All right. So that is the difference between frequency, relative frequency, and cumulative relative frequency. And you see the nice organizational structure of our data. So it allows us to see our data in a different way here. Okay. So let's dive a little bit deeper into it. So let's look at a different table. All right. So this is a different frequency table. And you'll see ranges, right? So we're looking at like how much of our data falls in between 60 and 61 inches. How much of our data falls in between 66 and 67 inches. So what we're going to do is just talk about some of the key terms from this table. So the first thing I'm going to talk about is what's called a lower class limit. Let me get a different color here. We have this thing called a lower class limit. All All right, and those are the numbers on the left side of these ranges. So this 60 is what we would call a lower class limit. And similarly, we would say this 61 is what we call an upper class limit, right? Because it's the upper boundary of that class, right? So we'd call that an upper class limit, right? That would be the 61. So the lower class limit for the fifth class, right? So if this is class 1, then we say class 1, 2, 3, 4, 5. The lower class limit for the fifth class would be 68, and its upper class limit would be 69. All right. So another key term that we need to make sure we're aware of is the class width. Right? So we're going to talk about this thing called class width. And that is how wide are these intervals, right? So going from 60 to 61, you might think, well, it's 1, right? Because it's going from 60 to 61. But really, it's actually got a class width of 2, and I'll show you why. The way that we calculate the class width is by taking 2 consecutive lower class boundaries. You can do this with any lower class limits here, right? So I can take these 2 lower class limits, like the 66 and the 64, and to calculate a class width, I would simply subtract them. So 66 minus 64 gives us a class width of 2. And you'll notice that that class width is the same width for all of the classes, right? So it's one of the requirements for our frequency table is that every class we create has to have a consistent class width. We can't go changing the widths of individual classes, all right? So class width, important. I might ask you to calculate that. It's real simple. Just take any 2 lower class limits, 2 consecutive lower class limits, and subtract them. All right, so the next one we're going to talk about here is what's called a class midpoint. And it's pretty self-explanatory what it is, right? So if I go into a class like, let's say, the 70 and the 71 here inside of this class, I'm asking you what is the middle point in between 70 and 71. And you might be able to figure that out because it's a really easy class. You might say, well, that's 70.5, Mr. Walton. And you are correct, but it's not always going to be that easy because the numbers aren't going to be like this. Sometimes it's a little bit more tricky to find that class midpoint. So the calculation that we use is to take an upper class limit, and I'm going to abbreviate here. I'm going to say upper class limit plus a lower class limit, right? So we would add those together and then just divide by 2. So for instance, if I wanted the midpoint of this class right here, I would do 71 plus 70, and then I would divide by 2, and that would get me a class midpoint of 70.5. All right. All right, so last term that we're going to discuss here is something called a class boundary. Class boundary. And you don't see these in the table. All right, you don't see them on the table. They're actually kind of hidden in the table. But a class boundary exists in between the classes, and I want to point this out. So notice that this class ends at 69 and starts at 70. So there's a gap in the data, right? So there's a gap. Like, what about numbers that exist in between 69 and 70, like 69.5 or 69.4? Where would that piece of data go? You know, like we have to make a decision. Where would it go in this class or would it go in this class? All right, so that's what the class boundary helps us with, and it's this invisible boundary that kind of tells us what to do with those in-between values. All right, and the class boundary is the midpoint in that gap, right? So we're looking at the midpoint between 69 and 70. So we would add 69 plus 70, and then we would divide by 2. Okay, so that would give us a class boundary of 69.5, and that would give us the class boundary in between here. All right, so if we did get a 69.4, we'd say, well, that's less than 69.5, so we're going to put it in this class. If we got something like a 69.7, we'd say, okay, well, that's more than 69.5, so we would put it in the next class. All right, so one of the things we want to avoid is putting a piece of data in more than one class, right? So one piece of data has to go in one class or the other. It can't go in more than one. And we also want to make sure that we avoid any data not getting put in a class at all. All right, so it has to go somewhere, and it can only go into one of the classes that you have on your frequency table. All right, So those are all the important terms, right? Lower class limit, upper class limit, class width, class midpoint, and class boundary. Those you need to know what they are, so that way when we talk about frequency tables, you know where to look. All right, so let's just go over the parts real quick one more time, right? So this question is, what is the first lower class limit? Okay, so I'm going to go back up to my table here and I say, okay, well, here's the first class, and the lower class limit there is 60. So I'm just going to write 60. All right, the second lower class limit, right? So I'd go to the second class, lower class limit is 62, right? It's pretty easy to answer these questions as long as you know where to look, right? So this one says, what is the fifth upper class limit? All right, so fifth class, 1, 2, 3, 4, 5. The upper class limit would be the 69. There we go. And then our class width, we actually calculated that here. And like I said, you can use any two consecutive lower class limits to figure that out because the class width has to be consistent. So we already know that our class width is 2. We calculated that. And then the next question here is, what is the first class midpoint? Okay, so I'd go up here. Here's my first class. I want to calculate that midpoint using my little formula here, right, for calculating midpoints. So I'm going to take upper class limit, which is 61. I'm going to add the lower class limit, which is 60, and then I'm going to divide that result by 2. And we would get 60.5. And this number will become important when we start making graphical displays. All right, so we will use that midpoint when we start making this thing called a histogram. All right, so this will be important later. All right, and then they want to know what is the class boundary between the fourth and the fifth class. So let's go count those out. So we got 1, 2, 3, 4. So here's class 4, and I'll change colors here. Let's see those. Let's go with green. All right, so 1, 2, 3, 4. So this class and this class. That's our fourth and our fifth class. So they want to know what is the midpoint in between those classes, right? What's the midpoint in between 67 and 68? So when I do that calculation, I would do 67 plus 68 divide by 2, and you would get a class boundary of 67.5. Okay, so there we go. All right, let's just do a little bit of analysis with it. All right, so what kind of questions does this kind of display help us answer? And you'll notice that I underlined some words here, so percentage and number. So when I see the word percentage, I'm thinking relative. Okay, is that relative part of the table is going to be very handy for answering questions about what percentage of your data falls within certain limits or certain intervals. And when we see the word number, I think frequency. Okay, so that frequency part of the table is handy for questions that ask about like what number of players had a height in between some number and some other number. All right, so let's go through these. It says the percentage of heights that are from 68 to 72 inches. All right, so I'd go back up to my table and let me clear some of this stuff out here. So we're looking for 68 to 72. So here's 68, here's 72, and I'm going to assume that they're talking about these two classes, right? Because 72, there could be some data values that are up to 72 in this class, but there are also data values that could be more than 72 in this class. So you start to see the limitation of how you set up those limits. So I'm just going to assume that we're talking about these two classes here, the 17 and the 12. Okay. And since we want a percentage, right? So remember that we had underlined percentage. I'm going to go over to my relative frequency column over here, right? And I got 17% of my players ended up here in this interval. Another 12% ended up here in this interval. So to get my total percentage, I could just add 17% and 12%. Right? So we would say 29% of players fell in between 68 and 72 inches. And we do the same thing. So it's about the same thing. The only thing they did was they increased this to 74. So if I went up here, I could now include everything in this class, but not everything in this class, based on the way that they asked that question. So now I could add 17, 12, and 7, right? So that'd be 29 plus another 7, that would be 36%. So this would tell us that 36% of our soccer players had a height in between these two values. All right. Now it says that once the percentage of heights that are more than 66 inches, all right, so I'd go up here and I'd say, okay, well, 66 inches starts right here. So they would want all of these, right? These would be all of the soccer players that had a height of more than 66. So, and since they want a percentage, I'd go through and add up all of the relative frequencies that we have here in this column. So I'd say 40, 17, 12, 7, and 1. So I'd add all of those up. And I believe if you do that correctly, you should get 77%. So we can say 77% of our sample, right, of our soccer players that we sampled had a height that was more than 66 inches tall. All right, so continuing on here, so notice this one says the number of players, and they want to know in between 61.95 and 71.95. So let's think about our class boundaries here. 61.95 is in between our two classes here. It's in between the 61 and the 62, but it would be more than the boundary in between, right? So 61.5 would be our boundary. 61.95 would fall into this class right here. And so it would fall into that second class. And so we're going to start here for this question, and they want 61.95 up to 71.95. So I would say that includes everything up to here. All right, because this next class might include some players that are taller than 71.95. All right, so I'm going to add up these frequencies, right, because they wanted the number. So I would add up these guys right here. And I think if you add those up correctly, you should get a grand total of 92 players. Right. And the last question here says, what kind of data are the heights, right? So heights are definitely quantitative. And since heights are measured, and you can literally choose whatever precision you want for heights, it would be continuous, right? So you could have somebody who's 69.2, 69.22, 69.00022, right? So there's an infinite number of values in between any interval, so that would make it continuous as well, so instead of discrete. So this is definitely quantitative, continuous data. All right, so just a bit of a recap. Remember, you count frequencies. To find a relative frequency, you divide the frequency by the total number of data values, and to find cumulative relative frequency, you add all the previous relative frequencies to the relative frequency for the current row. All right, so just a quick synopsis there of how to calculate those different things. All right, guys, I do apologize for all the construction noise in the background. Hopefully you found this video helpful, and if you have any questions, make sure you ask me in the Zoom chat. Have a great day.